Welcome back to another session of Cambridge IGCSE Mathematics under the Cambridge syllabus. In today's lesson, we're going to talk of the topic of functions in algebra. This is extended algebra topic, and from the word one can decipher the meaning of the word function as dependent. The function describes the relationship between two sets of numbers which are related to each other, where one particular set of numbers would depend on the other one. For example, if I got this set of numbers 1, 2, 3, they could be related to another set of numbers that doubles them, so that 1 is related or mapped onto 2 in a relationship where X set is mapped onto f of X. X now is a function of X now becomes 2 when we are doubling, and 2 would be mapped onto 2 times 2, 4. 3 is mapped on 3 times 2, 6. When you have a relationship where a set of numbers is mapped onto exactly one image, we call such a relationship a function. And we could write this relationship in the format saying that the function of X is 2 times X, where if we know a value for X, to get the image f of X, we just multiply by 2. Once we know that f of X is 2X, it is very easy now to find the image of 1. Say f of 1 will just be 2 times 1. Very easy to find f of 5. F of 5 will just be 2 times 5, 10. So if I'm told what the relationship between an item X and this function, if f of X is X plus 5, then I can easily find the image of 3, which is f of 3. That will be 3 plus 5. Giving me 8, okay? If I'm told, sometimes we use other letters. You can talk of g of x, which is x squared minus 1. So g of x, which is the image of x, says x is squared, then you take away 1. Then g of 3 will mean we square 3, get 9, take away 1, we get 8. G of 5 will mean we square 5, take away 1, we get 24. Okay? If two mappings occur at the same time, for example, f of x and g of x are occurring together, so if x is following g of x, and g of x was x squared plus 1, it would mean that f is now acting on x squared minus 1, sorry. So g of x was x squared minus 1. So if you have f g of x, that is the same as the function f acting on what g of x has done. Now, f of x adds 5. So f of x acting on this would give us x squared minus 1 plus 5. Okay? So if you wanted f g of 2, we already know the formula. We just say that would be 2 squared minus 1, which is 4, brackets plus 5, we get 8. Okay? If we reverse the processes, instead of fg, we now have gf of x. Now, g will act on what f of x has done. So g acts on x plus 5. Now g is squaring, taking away 1. So the result would be that this will be x plus 5 squared, take away 1. So if I want g of f of 1, I would end up with 1 plus 5 squared minus 1, giving me 36 minus 1, 35. So that's how we deal with functions. A function is a special relationship. The image is called the f of x. Okay? In previous relationships, particularly in linear coordinate geometry, f of x can also be referred to as y. So this expression sometimes can also be equivalent to y is equals to x plus 5, where y is a function of x. So in maths, realize that what you're calling y in the y coordinate system can be written as a function of x. Okay? So there is a close relationship between those two writings, where you're using y and where you're using just f of x. Okay? I would like you to work out the questions that follow, particularly pay note to where there are two functions together. We call that the composite functions, and work them out in that exercise. In the next lesson, we shall look at another item on functions. We'll see the opposite, the reverse of doing the f of x, or what we call the inverse function. Do the practice attached, and let's meet in the next lesson. Thank you.